The diagram shows a steel wire fixed at one end, and the other end is attached to a weight hanging over the pulley. So this is a weight, and yeah, we have an oscillator over here, and which is actually creating the waves. And see, the waves got this property that whenever waves strikes a boundary, they actually reflects back, okay? And from the waves through all these oscillators are actually returned back because of this pulley at this over there. And this pulley, the reflected waves from this pulley are actually creating a stationary wave, okay? And this stationary wave is right now forming one loop, right? So we have two nodes and one antinode, all right? That's how we classify points on a stationary wave, right? So the question is, which frequency of the oscillator produces a stationary wave with two loops? Now we need two loops like this. So which frequency will produce these two loops when one loop is produced by the frequency f, all right? So to carry on with this question, I want to intuitively show you how a stationary wave is formed. And for that, I've got a very cool simulation to show. Here I have the setup. This is the fixed end, this is the fixed end, and the end is having a clamp. And if I just move this manually, you can see the waves are reflecting back from that clamp thing. And it is actually, we can see if I move it more frequently, you can see that a stationary wave is formed, right? A stationary wave is forming. But now let's do it with an oscillator, all right? So if I shift this to an oscillator, yeah. So right now we have 1.5 hertz of the frequency, and you can see the standing wave. And if I want to figure out how many loops are there in this stationary wave, see, stationary wave is only formed when you have fixed end, all right? If there is no fixed end, if there is a loose end, there are no you cannot visualize any stationary wave. These are normal transverse wave, right? You cannot visualize any stationary wave. But as soon as I make it a fixed end, now you can see the difference, right? There's a standing wave forming up, right? Stationary wave is forming up, and I want to figure out at 1.5 hertz, how many loops am I getting? So I just pause the simulation at a particular point. So 1, 2, 3, and go. All right. So how many loops am I having? Okay, 1, 2, 3, 4. All right, so 1, 2, 3, 4. 4 antinodes, and because the maximum point is classified as an antinode, so 1, 2, 3, 4, 4 antinodes, and all right, so 1, 2, 3, 4. 4 antinodes and 4 nodes. Now, if I want to double this, all right, the question is about having two loops, so we'll double this, right? So in the next part, we want 8 loops. So how about if we just double the frequency, and all right, let's first run the simulation and doubling the frequency, making it 3 hertz. Let's see how many loops are we getting. So before, when it was 1.5 hertz, we are getting 4 antinodes and 4 nodes. And if I just pause the simulation at 3 hertz at any particular point, yeah. So how many nodes am I getting? All right, so 1, 2, 3, 4, 5, 6, 7, 8. Perfect. I'm perfectly getting twice amount of antinodes and nodes than the previous example where we have 1.5 hertz. So it clearly shows that if you double the frequency, you will get double the amount of antinodes and nodes. And at the frequency of f, we are getting how many loops? 1 loop. So if you want 2 loops, see, the question is, how do we get 2 loops? So we just need to make that frequency double, all right? So the correct option is option C, double the frequency.